Hello students, welcome to our VB Academy. So in this video lecture we are going to start a new subject, that is the strength of materials. Already we are running with engineering materials as well. We have completed with the 2 lectures and one more lecture is left for mechanical properties. I will upload it by tomorrow. Okay. So what is mean by strength of material? Actually we came across that is the property of material strength. Means whenever the load is applied on the body, if body is, means with which particular material the body is made, is resisting that externally applied forces, then that body is known as strength. Okay, clear? So body is means what here? If the body means the property of the body is what? Strength. If it is resisting the externally applied forces, clear, right? So resistance of externally applied forces, whenever the load is applied on the body, that is known as what? Strength of that particular body or material. Clear? So you are getting right. So strength of material. See here, strength of material. Strength of material, or this subject we call it as mechanics of material. What nana? Mechanics of material, or MOM, mechanics of materials, or we call it as solid mechanics. Solid mechanics. Solid mechanics. Basically we are dealing with here in strength of materials resistance bodies. So before going that, I will let you know what is meant by resistance body and the rigid body. So see here, solid bodies we can classify into resistance and the rigid bodies. What nana? Bodies means solid bodies we are classifying here. Rigid bodies, what nana? Rigid bodies and the resistance bodies, or resistance or resistant bodies. We can classify solid bodies into 2 categories, rigid bodies and the resistance body. What does it means? So see here, rigid bodies means in bodies, in which bodies if you apply the external force, it won't deform for that particular load, then that is known as rigid body. Means the deformation will be zero for that particularly applied force. In resistance body, the deformation won't be zero. The body deforms whenever you apply the load on that. That is the resistance body. That is what nana? Resistance body. Rigid body means what? The deformation won't be there. Means whenever you are applying the load, even though you are applying the load, the deformation won't be there for that particular load. Say I will give one example. No real rigid body exists in the real life. Clear? So what I am saying here, no rigid body exists in the universe. No rigid body exists in the universe. So see here, so this is the wall. I am applying the force with my hand on this wall. Okay, I am applying the force with my hand on this body. No deformation will be there in this wall. But if I apply the force, whatever the force I am applying with my hand, now I will change the application of force here. I will apply the force with the bulldozer, that is the earth mover. So then it will break, right? In single stroke it won't break, but 3-4 stroke it will break. Means that is the act as a resistance body for first and second stroke. Clear? So every body in the universe is a resistance body only. No such body called as a rigid body exists, but for our assumption, okay, we will assume that this is a rigid body. Clear? Is a rigid body where a delta L means change in length will be 0. Length will be 0 whenever the load is applied on the body. Clear? You are getting point, right? So basically these rigid bodies we will deal in the engineering mechanics. We won't consider about the deformation, where the load is acting on the body, what is the deformation and all those things. We will simply act the load on that and what is the resultant. We will find the resultant. Clear? With system of forces acting on the body, we will find the resultant. Clear? In the engineering mechanics. So the subject which deals in the engineering science which deals with the rigid bodies, behavior of rigid bodies whenever the load is applied, that subject is known as engineering mechanics. What nana? Engineering mechanics. What? Engineering mechanics. Engineering mechanics. But the subject with dealing with the resistance bodies means in which whenever the load is applied, the deformation will be there. That subject is known as strength of materials or mechanics of materials or the solid mechanics. Solid mechanics. Solid mechanics, or we call it as SOM, MOM, or the SM. We are focusing on these now. This is only what Nana? Solid bodies. If we go with the liquid and gases, we have different mechanics. Means fluid mechanics. Okay, fluid mechanics considers both like a fluid, means liquid and gases as well. Hydraulics means only water and liquid. Clear? And the gases means we go with the pneumatics and all those things will be there. We will cover in the that fluid mechanics. When we will teach the fluid mechanics, we will cover on the course things. So in this strength of materials, first thing we are going to start with the simple stresses and the strain. Simple stresses and the strain. So whenever the load is applied on the body, whenever load is applied on the body, what happens, Nana? Whenever the load is applied on the body, means say force is acting on the body. Force is acting on the body. If a body is rest, if the force is acting on that, it will move the body. That is the first condition. Clear? So first what, Nana? Force is acting on the body. What? Force is acting on the body. Force means what? The external agency which causes the body to move or body to come to rest or body to accelerate. If it is in motion, if you applying the more force, it accelerates the body, or it brings the body to rest, or it can develop the internal stresses. Clear? So we are mainly focusing on that internal stresses. Whenever the force is acting on the body, we are focusing on the internal stresses in this subject. And whatever else like accelerated, decelerated, we will cover in the engineering mechanics, in the dynamics and statics. Clear? Okay. So force means the external agency. Whenever it acts on a body, it will move the body, or body it comes to rest. Okay, or it accelerates the body, or it can develop the internal stresses. For specifying a force, it requires magnitude, nature of the force, clear, and direction of the force, and as well as the point of application. That are the specifications of the force. What, Anna? That are the specifications of the force. So say this is the body. This is a solid body. I am applying one force on this body on both sides. On both sides I am applying the force on this body, that is in the what, Nana? Pulling in nature. What, Nana? Pulling in nature. If you observe it microscopically, if you observe this body microscopically, what happens here means, see here, atomic structure will be there, right, Nana? Atomic structure means I am magnifying this and showing it like magnet. These all atoms are bonded with the cohesive force. What, Nana? Cohesive force. So if you applying the external force, what happens? This cohesive force start breaking. After what, Nana? These cohesive force also possess some new magnitude, right? So it possesses also some magnitude, means it also have some resistance against this force. Even though you are increasing the force, it will deform. It will deform against which force? This force. Means this cohesive force resisting this body to deform under this externally applied force. Are you getting clear, right? So this is the external force P I am applying on this. If I again magnify this, see here, say this is a series of molecules. On single line, say I am applying the force P now. Even though if you are applying the forces like this on this body, pulling nature, what happens here? The cohesive force in between these two molecules will start breaking. Till one point it will resist, but after that, if you are increasing, even though you are increasing forces, what happens here? It will start breaking. But this resistance force means whenever the external force is acted upon the body, the internal resistance force developed per unit area of the body is known as what, Nana? Stress developed by the body. And this internal resistance force has to be same such that whenever this externally applied force. Means this internal resistance has to be same as that the externally applied force. That force per unit area of the body is known as stress. Very clear, right? So see here, what is happening here? You can check, whenever the load is acted upon the body, it developing internal stresses. Why, Nana? The molecules with which the body is made, the cohesive force in between the molecules resists the externally applied forces. And it causes to what, Nana? To prevent the deformation. That resistance force per unit area of that body is known as what, Nana? Stress. And this resistance force has to be equal to the what, Nana? The externally applied forces. So see here, this is the force. I am applying push nature force now. Push nature. Now what happens? It comes together. Means it will again resist the what, Nana? This externally applied force. Clear? So what is meant by stress here now? Check. Stress. What is meant by stress, Nana? Here, stress is what? It is the what, Nana? Force per unit area. Which force? Resistance force. And that resistance force is equal to what, Nana? Externally applied force. What, Nana? Externally applied force. This is known what, Nana? Stress. Clear? So what is meant by force here? The resistance force what, Nana? The resistance force or applied force, both are equal, Nana. Applied force, resistance force or applied force per unit area of body. See here, stress denoted by sigma is equals to load per unit area. Load means force, Nana. What is the SI unit of force? SI unit of force is Newton. What, Nana? Newton. And SI unit of area means what, Nana? Length, which is what, Nana? Meter square. So what is the unit of stress here? SI unit of stress is Newton per meter square. This is also an important bit, Nana. This is also an important bit. What is the SI unit of stress? Based on application of force. Means if you are applying tensile force, then the development of stress will be tensile in nature. If you are applying the compressive force, then the development of stress will be in the what, Nana? Development of stress will be in the compressive nature. If you are applying the shear stress, I will let you know. Okay, shear force means the force which is able to cut or divide the body into two equal parts. That is known as shear. Clear? So if you are applying tensile force, the development will be tensile stress. If you are applying the compressive load, then the development of stress will be compressive in nature. If you are applying the shear load, then the development of stress will be what, Nana? Shear in nature. So one more thing you have to see here, whenever you are applying the load here, see here, whenever you are applying the load, body is getting deformed, right? Body is getting deformed. Clear? So this is the initial length L0 and this is the final length LF. What, Nana? Initial length is what? L0, final length is what? LF. Clear? This is the force P. This is the 2D diagram, Nana. Here you can check, this is the 2D diagram. So change of dimension to the original dimensions. What, Nana? This is the change in dimension, means LF minus L0 will be gives you the change in dimension. What is the dimension change? Means length. Clear? So what is change in length here? LF minus L0. Because due to elongation, the LF will be greater than what, Nana? LF will be greater than what? LF will be greater than L0. Means L0 is the original length, LF is the final length. Will be what? Greater than the original length. Clear? So change in original length to the original length, that gives the strain. What Nana? Change in dimension. So how to define the strain? Change in dimensions to the original dimension. If you consider the 3D body, say we are considering 2D body only here. If you consider 3D body, so this is a 3D body. You are applying force perpendicular to this. You are applying force perpendicular to this. You are what Nana? Pulling the body. Pulling the body. Due to pulling of this body, what happens? Pulling of this body along length you are pulling. Along the length. This is the length. This is what Nana? Length. Along the length you are pulling the body. What happens? Length will increase, but other two dimension, height and breadth, will be decreased. Will be decreased. You are getting point? That is also a strain. That is also a strain, Nana. Means that's why we are defining the strain as what Nana? Change in dimension to the original dimensions. What happens here? Whenever you are applying the pulling nature force along the what? Length. Along the direction of length. This length will increase and both other two dimensions, breadth and the height, will decrease. Breadth and the height will decrease. Clear? So how to define the strain, Nana? How to define the strain? Strain is the what, Nana? Change in dimension to the original dimension. Change in dimension to the original dimension. Then what is the unit of strain, Nana? Unit of strain is what? What is the unit of strain? No units will be there because both the parameters are same, length by length. Length by length means no dimensions will be there. That is the dimensionless quantity. Clear? So what, Nana? Strain. What is strain? This is denoted by epsilon. What, Nana? Epsilon. Okay. See here. Change in dimensions to the original dimensions. Change in dimension to the original dimensions. Change in dimensions to the original dimension. Say if you are applying the pulling nature force, see here, this is the called as primary strain, which is epsilon p, which is denoted by delta L by L or delta B by B or delta H by H. Delta H by H, whatever it may be. Okay, so primary strain means what you can check here, whatever it may be. If you are applying the force along the length, then the length will increase. If you are applying the force along the breadth, then the breadth will increase. Other two dimensions will be what? Whatever it may be. Means it will be decrease. Clear? So delta H by H means if you are applying the force along the H dimension means height, then height will decrease. Clear? So this is the primary strain or delta H by H means whatever it might be based on the direction of application force. Means the strain developed in the direction of application force, that is known as what, Nana? Primary strain. What, Nana? Primary strain. The strain developed along the what, Nana? Along the what? Application of force, that is known as the primary strain, and the direction means other than this application of force, that is known as secondary strain or the lateral strain. We called it as what, Nana? Lateral strain. Say if you are applied the force along length direction, then delta B by B and delta H by H will be secondary strains. If you are applying the force along breadth means B, then delta L by L and delta H by H will be secondary strain. Secondary strain means other than the direction of application of force. Clear? Hope you got right. So what is meant by strain here? What is meant by strain here? So we came across what, Nana? In engineering materials, we came across tensile test diagram. Tensile stress diagram means within the proportionality limit, within the elastic limit, what happens here? Within the elastic limit, the stress is directly proportional to the strain. Or within the proportionality limit, within the proportional limit, the stress is directly proportional to strain. We drawn one, what, Nana? A straight line, uniform line. That is the direct relation will be there between stress and the strain. This is called Hooke's law. What, Nana? Hooke's law. I will let you know later. Before going to like stress divisions, we will know means how to like tensile stress. What is meant by tensile stress? What is meant by compressive stress? What is meant by shear stress? Okay. Before first going to with that, we will clear that. Okay. So you wrote it down right. What is, Nana? Stress. The resistance force or the applied force per unit area is known as stress. P by A, and newtons, SI systems are what, Nana? SI systems units are what? Newton per meter square, and strain is what? Change in dimension to the original dimension. This is the primary strain. Primary strain, Nana. Primary strain. Clear? Okay. Hope you got this. So then coming to the next types of stresses. Types of stresses. Types of stresses. See here, types of stresses. Types of stresses. Shall I rub this? Okay, we'll rub this. Types of stresses. Types of stresses. Types of stresses. First one is what, Nana? Tensile stress, compressive stress, and shear stress. What, Nana? Shear stress. What, Nana? Shear stress. First was one, what? Tensile stress, compressive stress, shear stress. See here, this is the body. I am applying the load which is in the pull in nature. Pull in nature load is P, and the cross section area is A. Cross section area is A. And in this compressive nature of force, I am applying the force which is in the push nature, and that is the P, and the area is A. Area is A. And here in shearing nature, I am applying the force which is parallel to what, Nana? Which is parallel to area of cross section. That is also say P, and area of this, or area under shear, is A. Area under shear is A. Clear? So see here, tensile stress. What type of load we are applying on the body? Pulling in nature, means tensile force. See here in the compressive force or the compressive stress, what type of force you are applying on this body here? That is in the compressive nature, which is called compressive force. Due to this, which type of stress is developed in the body? That is the compressive force. Compressive stress. Here the shear. Shear means what? Shear means the force which is cutting the body into two pieces. Two pieces means having the ability to cut into two pieces. That is a shearing force. Scissor. Clear? So in this case, in this shear case, the load has to applied parallel to the axis of what? So parallel to the force, means parallel to the what, Nana? Parallel to the area of cross section. 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 This is the area, right? This is the area of cross section, right? If you are applying the force parallel to this, if you are applying the force parallel to area of cross section, then that is, the force is known as shear force, and the developed stress is known as shear stress. Shear stress, and denoted by tau. This is the tau. This is the direct shear stress here developed. So what is, Nana? The internal resistance per unit area. This what is, Nana? This is the area under shear. Area under shear means this you have to take. Area under shear means this area will be get into two parts. This area will be get into part means this area we have to take. This area. And units are what, Nana? Newton per meter square. Newton per meter square. Newton per meter square. Here sigma T. Sigma T is what, Nana? P by A. Newton per meter square. Newton per meter square. Here sigma C means sigma C is what, Nana? P by A. Newton per meter square. Newton per meter square. This is what, Nana? This is the tensile stress, and this is the compressive stress. This is shear stress. This is what, Nana? Shear stress. First one is what, Nana? Tensile stress, compressive stress, and shear stress. Means these two forces or these two stresses are developed by which, Nana? What, Nana? Whenever the force is acting perpendicular to the area of cross section, here check, you can check here. This is the area, Nana. This is the area, and perpendicular to this area of cross section, these two forces are acting, called at normal. These two are what, Nana? Normal forces. or axial forces, you came across what, Nana? First thing is what? We are dealing with the strength of materials, in which we are going through the simple stresses and the strain. What is meant by stress? What is meant by stress here? Whenever the load is acted upon the body, it will resist the externally applied body due to cohesive forces of that particular body molecule. Clear? So that resistance force per unit area, which is equal to externally applied force, is known as what, Nana? Stress. Is known as what? Stress. Clear? So due to this application of forces, what happens? The body get deformed. Deform means the change in dimensions. Means initially when the load is not applied and the load is applied, the change in dimensions, the deformation, is known as what, Nana? Strain. Change in dimension to the original dimension, that is known as strain. You can check here, as we are specifying, this is the tensile stress. Whenever the tensile stress is load, means developed in the body, tensile strain will be developed. Means whenever you are applying the tensile load, it will develop the tensile stress. Same thing, tensile strain as well. Okay. Compressive strain means what? Whenever you are applying the compressive load, it will develop the compressive stress and respective compressive strain as well. Here also same strain, it will develop. Clear? You are getting right? So first is what, Nana? We completed with the strain as well. Clear? So in the next class we will go with the different types of strain and the elastics constants. Okay, hope you got this content. Okay, thank you for watching this video. Please do like, share and subscribe to our VB Academy and comment below in the section. Thank you.